Okay, we're going to view the animation's path and manually edit the keyframe properties. So when adjusting animations, it is useful to see the camera's path and keyframes so that we can move to a keyframe and adjust its properties such as Z evaluation, so the camera location. Now on the animation timeline, we double click one and we zoom in, and on the animation tab in the display group we will click the path, and then this step turns the camera path and keyframes on to better see how the animation plays. Keyframe 2 is a little too high, so we will edit its property to lower the keyframe. So on the animation timeline in keyframe gallery, we will double click here. So now we can see the path. Number 2 is click number 2, and on the animation tab in the edit group we will click the property button. So edit, so this is property, this is keyframe shift right here. Oh, property is this one there. So the property, and we have the property here, and we will expand the camera and type 100. Camera type 100 for Z value. Right now we have, should be 2. And Z value, we will say 100 for 1000 for the Z value. And 2 will be here. Cool. This is really cool compared to the arc scene. And now we're going to play the animation from the beginning. So, alright. So I'm gonna back in here and play. And I want to move 2 here. Yeah, and then 3 here. Yeah, the timeline got messed up. Alright, and then I want some time here and some time here. I don't know whether it would change. Okay, now it's more. Alright, this thing, gonna go back. Okay, let's play again. So from 1, 2, and then 3 going down. Okay, turn around. Yeah, very good. And then you can see the property and you can change the value. And remember 5 and 6 we pause. And this pause I changed it for a long time. And we can just drag it, make it shorter. There. So there. So you just change the keyframe here and make it nice. Okay. Perfect. And we will create a movie from the animation. Now we will have created an interesting animation. It's time to share the animation with others. So to share the animation, we will export as a movie file. So I will just go to export movie right here. So export movie file, and we have several options, including exporting your movie directly to YouTube, Vine and Vino and so on, or as a draft animation we can change the file location and movie resolution, type size, and so on in the file export and advanced movie settings. So on the animation tab in the export group, we will click the export movie button. So I'm gonna do it now, export movie button. So right here, movie. And now we can do everything here. So on the animation tab in the export group, we click the export video. So this button in the export movie pane. So in the movie export preset groups, we will click the draft button. So draft button, so right here, which is this one there, and then draft button, and this step will create a smaller file. The resulting quality of the file isn't high, but it's much faster to produce. So under file name, we will click the browse button, navigate. So I think, let's see, I don't want to save it here, so I just go back to my desktop, And then, yeah, ArcGIS Pro, it will be in chapter 11, our animation scene, that's fine. Chapter 11, 3D as the movie name, and file, I think everything this is fine, or I can just do MP4, it's smaller. And in the export movie pane, we will just click save, and then file export settings. All right, everything is fine. So wait a while for the movie to be created. If we use other settings for higher resolution or a larger size, the movie can take a long time to render. So we can save the media format as separate JPEG files that we could use later, stitched together using another animation software application. So we can play our movie when it's done. So it's fast. So remember that ArcScene gonna take a long time, but for ArcGIS Pro it's a lot faster, so it's a lot nicer. So that I'm going to go back here and we can play. So this is still huge. If we can say from here, okay. Right now it's done. All right. So now gonna play real quick. So we're gonna play real quick, and you can see it's not that good quality because my building is still shaking. Okay, now see, this part is shaking. Actually, it shouldn't move. Yeah, the rendering has some issue, but it's a good animation anyway. Cool. That's everything for chapter 11. Then we're gonna do a quick summarize it. Okay. Okay, there. So we did a lot, and we finished this part: geoprocessing, digitizing. I don't like geocoding. Hopefully, I don't have to deal a lot with geocoding. Collector. We will talk about collector, model, builder tasks, and operator dashboard for managing system with a GIS. So that will be chapter 12 and chapter 13. So ArcGIS Pro 3D, it's a robust tool for creating and adding 3D features. Tools and functions are constantly added, so check Esri website often for updates. It updated a lot, so you have to follow every day. Not every day, at least every week. 64-bit application, new graphics engine, and modern interface, seamless 2D and 3D, can directly apply procedurals, symbols as rules, shadowing, modeling, seamless web scene integration. And now we have a common ArcGIS Pro 3D functions: create ting, triangulated irregular networks. Ting is defined by two elements: a set of input points with x, y, and z values, and a series of edges connecting these points to form triangles. Creates and adds 3D features. Use line art to create 3D buildings. Integrates features from city engine rules. Creates animations that we did. And global scene. Global scene is just like ArcGIS, ArcScene. In the old version. So instead of, see, the feature, everything is the same. Instead of just open one button, here the old version made you to go, I'll go to start, and you have to go to ArcGIS product stuff. So then you go through ArcScene, ArcGlobe, but in ArcGIS Pro, you just go to Pro. Everything is there. So now, global scenes are used for a large extent of real-world content where the curvature of the Earth is important, so that you can do more accuracy stuff. And local scenes are used for smaller extent content in a projected coordinate system or cases where the curvature of the Earth isn't needed. Allowed users to clip features to study areas, use triangulated irregular networks, and are often used when clipping features in a local scene. So digitized feature on surface is difficult for 3D. So I might still have to get used to it and use tables and procedure symbols to display realistic features. So generate building heights using LiDAR data. So the light detection and ranging. Remote sensing technology producing high resolution topographic maps, elevation. So airborne, laser scanner combined with onboard GPS and operation pitch, roll, and yaw data acquired by USGS from vendors, government agencies, data, 3D point data of latitude, longitude, and elevation. So laser file format, LAS. Oh, laser file format. I don't know the previous one. I thought it was LiDAR area survey. With classification of object type, bare earth, high vegetation, buildings, etc. So high resolution centimeters accuracy, ground detection is forested terrain, digital elevation model, raster map derived from elevation point data via interpolation methods, available for free from Earth Explorer. I never use Earth Explorer. I might have to explore and see. So that's how they collect the GPS base station, the GPS, and they fly. So the schematic diagram for airborne LiDAR, performing line scanning result in parallel lines of measure points other than patterns exist, but this one is fairly common. So sample LiDAR, so the sample LiDAR, we don't need this, okay. GPS base station, okay. So now sample LiDAR application that we have the FEMA Q3. So LiDAR derived flood plain used to delineate flood boundaries, contrasted with previously mapped Federal Emergency Management Agency (FEMA) flood zone boundaries. So simple LiDAR application. So LAS file. So I guess it was the laser file format. Industry standard format for storing airborne LiDAR data, binary file format, developed by American Society for Photogeometry and Remote Sensing. Oh my god. So I was the vice president for the ASPRS. Individual record for each layer, pulse recorded, directly readable by ArcGIS Pro. LiDAR data storage. So compressed format of LAS file, faster processing, especially over network. So the easy elevation, the Z. So free download to optimize LAS files. No need for ArcGIS to use it. And next will be step for creating building heights using LiDAR data. It was fun that we did in our lab. So create the LAS dataset, generate a digital surface model and a digital terrain model. And subtract the DTM, the digital terrain model, from the digital surface model to create a normalized digital surface model. So create random points for buildings and add surface information to buildings using the normalized digital surface model, and use summary statistics to assign a maximum height to the buildings. Join building statistic table with max height to building footprints. And the DTM, DSM, and NDSM. So digital surface model, that it was a first return surface that represents a shrink wrapped surface of the earth, including buildings, trees, and other obstructions. So digital terrain model, a bare earth terrain surface created using ground returns only. Normalized digital surface model, the difference between the digital surface model and digital terrain model surfaces, or a digital surface model normalized to the bare earth surface, can be used to calculate building, tree, or other feature heights. And create a LAS dataset. A LAS dataset created from original LAS data provides fast access to LiDAR data without the need for data conversion, making it easy to work with LAS files for a specific study area. The filter LiDAR first return points before. Yeah, it was the first return that before generating a digital surface model raster filter, first return lines or pause most significant return and associated with the highest features in the landscape, such as a treetop or the top of a building, save processing time. So generate a digital surface model that I created, and then we will filter ground points before generating digital terrain raster, filter ground line